Okay, good morning, Victor, Kiefer, Tyrone, and Renato. So today we have a lot of grounds to cover, kaya medyo simulan ko na kahit aapat pa lang kayo or lilima pa lang tayo. But before we start, some housekeeping matters first. Mamayang 5 p.m. lalabas na yung problem set, yung midterm exam nyo. Just remember, you have only until Monday, right before midnight, that's 11:59 p.m., to submit the problem set. When we have time later, I will give you some idea of how the problem set will look like. Though parang fake news yung sinabi ko last time na 3 hours kaya nyo siyang tapusin in 3 hours. Though kaya pa naman, pero siguro mga 5 hours yung i-allot nyo para dun sa problem set. And again, I'll be strict with the deadline because this was supposed to be a face-to-face exam. So, magiging strict ako dun sa submission deadline. So, wala na akong tatanggapin na late submissions after 11:59 on Monday. So, kung bigla kayong mawala ng internet towards the end of the day, then that's your problem. So that's why you need to plan ahead and probably allot a couple of hours before the deadline para ma-submit yung problem set para meron pa kayong chance para humanap ng alternatives. Okay? So because again, I'm going to be strict with the deadline for the midterm exam. But more on that later, because the coverage of the problem of the midterm exam is until section 3.5, and I think we have a couple of topics left for chapter 3.4. So kaya kailangan na natin siyang simulan. So, but essentially last time we talked about this several theorems involving involving the general linear differential operator in terms of with constant coefficients, yung f of d natin. So in particular, little f is just a polynomial. Pag meron kang polynomial, papalitan lang natin yung mga variables by the differential operator d. Tapos kung whatever this guy is, pag in-apply mo siya kay e to the mx, tas in-equate mo kay 0, kapag meron kang operator, in-apply mo kay e to the mx, and you find a constant little m that will make the polynomial f equal to 0, then that means this differential operator or the image of this differential operator will be equal to 0. Ibig sabihin, kung meron kang equation na f of d applied to y ay equal kay 0, where f is a polynomial, then sure tayo si y equals mx is a solution of that linear differential equation if m is a root of the polynomial. So ang tawag natin kay f is it's the auxiliary. You can spell it this way. Ang spelling yata dun sa later sa slides ay auxiliary na ganyan. But anyway, they are the same thing, tomato. So auxiliary polynomial, some books call them as the characteristic polynomial. So that means if you have a polynomial little f, tapos pinalitan mo lahat ng variables by the differential operator, you apply it to y and equate the answer to 0, then the solution for that linear differential equation is tantamount to just finding the roots of the characteristic or the auxiliary polynomial. And that's what we have seen in our last example last time. But again, you need to be a little careful here. Hindi natin sinasabi na yung makukuha natin na solutions o na functions mula kay roots ng characteristic polynomial ay sila lamang yung mga solution. We know for sure that they are the solutions. But hindi natin alam sila lang ba yung solutions. Of course, it's a homogeneous equation, so the sum of solutions is indeed another solution. And actually, we have a theorem before that tells us that the linear combination of any solution or any set of solutions to a homogeneous differential equation is another solution. So dito sa example na to, nakita natin si e to the 3x at saka si e to the negative x ay mga specific solutions ng differential equation na to. So that means by the superposition principle, kumuha ako ng kahit anong linear combination ng dalawang solutions na to, then we get another solution. All right? So this guy here solves this differential equation. But the nice thing to ask is, sila lang ba yung solution? Lahat ba ng solution sa differential equation na to ay kayang isulat like this? So basically, I'm asking, is this the representation for the general solution? That is, are all solutions of this form for some constants C1 and C2? Well, nakita natin sa previous sections that there is a condition for that to happen. That is, e to the 3x must be linearly independent with e to the negative x. Ito yung diniscuss natin in the earlier sections of chapter 3. So paano mo ma-check yung linear independence nitong dalawa? Kunin mo yung Wronskian. Right? Kapag ka yung Wronskian ay hindi palaging 0 sa isang neighborhood nung x, ibig sabihin linearly independent sila, ibig sabihin any solution will be of this form. Alright? So pero dahil hindi natin yung ginawa, medyo careful ako dun sa aking statements dito. Sinabi ko lang, si e to the 3x at saka si e to the minus x ay mga solutions. Hindi ko sinabi na sila lang yung mga solutions. I could have gone a little bit further and said that C1 e to the 3x plus C2 e to the minus x is also a solution to the differential equation for any constant C1 and C2. That's fine. But without any proof of linear independence, I cannot say na ito lamang yung solutions dun sa differential equation. But we'll see some theorems that will guide us on the solution set of this ODE mamaya sa section 3.5. So, but before we go there, just a quick example again of what we did last time. Halimbawa ito, humanap daw tayo ng solutions. Medyo generic yung question. Sinabi lang, maghanap ka ng solution. So if we can find one solution, then that's fine. Hindi sa atin pinapahanap ano yung general solution. Humanap lang daw tayo ng solutions because that's the only thing that we have basis for so far. Alright? Yun lang yung alam natin gawin ngayon. Pero mamaya, dadagdagan na natin yan kasi yung isang problem sa midterm exam nyo ay involving itong general linear differential operators. Okay? But here, what we'll do is to first define the auxiliary polynomial. So here, the auxiliary or the characteristic polynomial, the auxiliary polynomial for this ODE, tawagin nating star yung ODE natin. So the auxiliary polynomial for star is little f of m equals m cubed plus 2m squared minus m minus 2. So yung auxiliary polynomial, palitan nyo lang yung ng indeterminate little m, lahat ng differential operators. And we have seen kapag ka merong, so ito ay pwede mong isulat na f of capital D applied to y equal kay 0. Sabi nung remark natin before, yung pagsosolve ng differential equation na to boils down to finding the roots of the auxiliary polynomial. Kaya kinumpute ko yung auxiliary polynomial, ang goal ko ay hanapin yung roots nito. Alright? But to find the roots, pwede ka mag-factoring. Try nyo kung pwedeng ma-factor yung m cubed plus 2m squared minus m minus 2. I can do factoring by grouping. I can group the first two terms, factor out the common monomial factor, which is m squared. May matitira na m plus 2 minus, sulat ko lang to na m plus 2. Alright? Magkagrupo naman yung third and fourth terms. And then the two groups has a common factor, m plus 2. So I can factor out the m plus 2 from the two groups. We'll have m plus 2 times m squared minus 1. Right? So therefore, the roots of f are negative 2 coming from this factor, all right? Kasi ang gagawin mo, i-equate mo to sa 0, mag-0 lang ito kapag ka si m ay negative 2 o kaya si m ay plus or minus 1. So we found three roots to our auxiliary polynomial, and from these three roots of the auxiliary polynomial, we can get one solution apiece for the differential equation. So we can say, thus, by the previous remark, y equals e to the negative 2x, y equals e to the x, and y equals e to the negative x are solutions to the differential equation, right? So that's one thing that we know for sure. Si e to the minus 2x, pag pinlog in nyo dito for the y, you will get an identity. And so on for e to the x and e to the negative x. Again, you can go further. Moreover, we can say that a linear combination of these three solutions are also solutions to the homogeneous differential equation. But be careful, pwede nyo lang itong gawin kapag ka homogeneous yung differential operation, yung differential equation, right? So dahil homogeneous naman yung ODE natin, meaning zero yung right-hand side, alam ko na yung linear combination ng tatlong solutions na nahanap natin ay solutions din ng DE. Is also a solution of star for any constant C1, C2, and C3. Okay? Now, but again, there's a question that lingers in the background. Sila lang ba yung solution? Ito na ba yung general solution? Well, if you want to know the answer to that, find if e to the negative 2x, e to the x, and e to the negative x are linearly independent. And for you to do that, you need to compute the Wronskian. All right? Pag napakita mo na linearly independent, itong tatlong solutions na nakita mo, then you can say that ito na talaga yung general solution. Lahat ng solutions will be of this form. Okay? Is that clear, guys? Klaro ba yung mga remarks na siningit ko? All right, so I hope it is. Okay, good. So yon, pagalingan tong mag-solve ng roots ng characteristic polynomial o ng auxiliary polynomial. By the way, I'll switch between terminologies. Minsan tatawagin ko si little f na auxiliary polynomial. Minsan tatawagin ko siyang characteristic polynomial, but they are just the same thing. Minsan i-spell ko yung auxiliary na double L. Minsan LIA yung gagamitin kong spelling. So, but everything is okay, all right? So we can use them interchangeably. Okay, now we have this, but we have another pair of theorems here that will give us more insights on how to solve homogeneous differential equations involving an auxiliary polynomial, you know? And prime to that is theorem 3.4.4, which sort of give us as a way on how to work with operators of the form d minus m to the upper n, where m is a constant. Okay? Sinasabi ng theorem 3.4.4, pag ang operator d minus m to the n, ibig sabihin, i-apply mo si operator d minus m sa function e to the mx times y, n times ng sunod-sunod. Then sabi niya lang, sabi ng theorem na to, okay, madali lang yan. Ilabas mo lang yung e to the mx dun sa harap ng differential operator, parang magiging shifting yung epekto niya. So pag ito, nilabas mo dun sa differential operator, mawawala lang tong m, magkakaroon ka lang ng nth derivative ni y. Okay? But the crucial thing here is the subtrahend here must be the same as the coefficient to the x in the exponent of e. Dapat magmamatch itong subtrahend na to at saka yung exponent na yan. Okay? Tapos dapat constant yung coefficient, constant na 1 yung coefficient ng differential operator. So be careful about this form, all right? But again, the nice thing about this form is you can just put e to the mx out of the differential operator. Ilabas mo lang siya. Tapos ang epekto ng paglalabas ng e to the mx, nawawala lang yung subtrahend. So naging nth derivative lang siya ni y, and this is much easier to handle. Kasi here, hindi mo na kailangang gumamit ng binomial expansion para makuha si d minus m to the upper n, or the operator d minus m applied to this convoluted function n times. Kasi ito ay medyo, pag in-apply mo pa to ng mano-mano, kailangan mo mag-product rule every time or every step of the way, because this is a function of x, this is another function of x, you have a differential operator here, magpa-product rule ka pa. Tapos gagawin mo siya n times, that's a very tedious process. But thanks to this theorem, Yeah, madali lang pala yung mangyari. E to the mx lang, lalabas lang siya, tapos times the nth derivative of y, no need for the product rule. All right? And no need for a binomial expansion. But this is a nice theorem, but I will not present the proof to you. So yung proof niya pwede niyong gawin by principle of mathematical induction. Katulad ng ginawa natin in a previous theorem earlier. What is important for us in this theorem ay paano siya ina-apply. Matutunan natin kung paano siya ina-apply sa isang or sa pagsisimplify ng mga um, ng um, ng mga ng mga um, pagsisimplify ng result pag in-apply natin yung operator na d minus m to the upper n sa isang function ng itsura ay e to the power mx times y. For instance, let's look at the three examples we have here on the slide. So, una, kunin daw natin yung d minus 3 squared apply to e to the 3xy. Again, if you want to do it by hand, i-apply mo muna yung d minus 3 sa e to the 3xy. That will be tedious because you need to differentiate e to the 3x times y, both of them being functions of x, so magcha-chain rule ka pa. Pero tingnan niyo yung form. Ang ganda ng form niya kasi yung m, yung subtrahend ay 3, yung exponent ni e ay merong 3x. So the coefficient here and the subtrahend here match. Subtrahend lang pala, so yung constant na 3 lang yung kailangan kong tingnan. Sabi ng theorem 3.4.4, easy lang yan. Ilabas mo lang yung e to the 3x times the second derivative of y. And that's it. Right? So here, n is equal to 2, and m is equal to 3. The subtrahend is 3. The coefficient to x in the exponent of e is 3. Then theorem 3.4.4 applies. Okay? Similarly, for example 2, again, here the subtrahend is negative 3 because you need to write it as d minus negative 3 raised to the 5th power. So, ibig sabihin, 5 beses mo i-apply yung operator d plus 3, pero kanino? Kay e to the negative 3x. Yung subtrahend dito ay negative 3. Yung coefficient sa exponent ni e ay negative 3. I-apply ko siya. So, easy peasy. This will just be e to the negative 3x, 5th derivative ni y. Okay? Now, the third problem is a little bit more complicated because this will not conform to the theorem. Kasi ang sabi ng theorem, dapat d minus m. And look at this, you have a 2d minus 1. So kailangan muna natin itong i-simplify. All right? So in that case, kailangan kong persahin yung issue na yung operator na to maging itsurang d minus m to the upper n. I am keeping my fingers crossed that whatever subtrahend we will end up here is the same as the coefficient to the exponent of e. Right? Ang exponent ni e ay 1/2 x. So I'm hoping na yung subtrahend dito maging 1/2. And actually, that will happen because we need d to have coefficient 1. So ang kailangan kong gawin, mag-factor out ako ng 2 dito sa operator na to. Right? So ipupwersa ko yung issue na magpa-factor ako ng 2. So magkakaroon ako ng d minus 1/2 raised to the 3rd power e to the 1/2 x times y. Okay? And then I will use the associative property and the power rules dun para sa operators. So basically, the operator here is just 2 cubed times d minus 1/2 to the 3rd e to the 1/2 y, or e to the 1/2 x times y. And look at this now. The operator is d minus 1/2 or d minus m, where m is 1/2. 1/2 happens to be the exponent or the coefficient to the exponent of e. So at this particular point, mag-a-apply yung theorem 3.4 dito sa expression na to. All right? Essentially, this will be 2 cubed, which is 8. Tapos lalabas yung e to the 1/2 x. Tapos third derivative ni y. And this is much easier to manipulate rather than this guy. All right? Kasi ayun nga, magpa-product rule ka 3 beses. Yeah, and that's not pretty to do, especially because the number of terms will grow as the order of the derivative increases. Okay? Is the theorem good? I hope it is because kailangan ko siya dun sa susunod naman na theorem. Ang problema lang dito ay kailangan yung sa uluhin, ano? Pero lucky for you guys, take home yung midterm exam, so you will have the benefit of your notes to work on this, all right? So, corollary to, or actually, yeah, to theorem 3.4.5 is, theorem 3.4.4 is this theorem, which I call the exponential shift theorem. Okay? Sinasabi lang ng exponential shift theorem na kapag ka meron kang auxiliary polynomial little f, tapos yung indeterminate, pinalitan mo ng derivative operator, then you can sort of shift the operator by factoring out an exponential function. So, ibig sabihin, kapag ka meron kang, kapag ka si auxiliary polynomial f ay in-evaluate mo sa operator d minus m, and then apply the result to e to the mxy, ang sagot lang ay e to the mx f of d applied to y. So, which is very similar to the previous theorem, okay? Kasi kanina, pwede mong isipin kanina ang ating auxiliary polynomial ay m to the n. Alright? So yun yung nasa theorem 3.4.4. Ito ay mas mas generic na version ng equation 3.4.4. O depende kung paano mo siya titingnan. Pwede mo tong tingnan as the generalization of 3.4.4 or as a corollary to 3.4.4 because the proof of theorem 5 will rely on theorem 4. Okay? Pero ang idea ay ganun pa rin. Kapag ka i-apply mo yung operator f of d minus m, kaya siya tinawag na shift kasi yung differential operator na d ay shifted m units. Instead na d, naging d minus m siya. So na-shift m units to the left yung ating operator, ano? Tapos in-apply mo siya sa e to the mx times y. Parehas yung subtrahend at saka yung exponent ni e. Well, this could easily be done by putting e to the mx out of the operator. Pag nilabas mo yung e to the mx ng operator, nalagay mo siya dito, ang epekto lagi nun, nawawala yung minus m. Alright? So that's why when I move e to the mx outside, it will be free of the operator. Hindi mo na siya kailang i-subject dun sa operator f of d. Pero ang nangyayari, nawawala yung minus m, which makes the evaluation of this guy much easier. Okay? Pero usually, kakaiba yung gusto kong mangyari. Baligtad yung gusto kong mangyari. Usually, we start with this guy, and then I want to come up with this. How is it done? Halimbawa, meron akong... so, ito yung gagamitin ko mamaya. Pag halimbawa, meron akong f of d minus m factored to y equal to 0. Medyo mahirap itong i-evaluate because yung auxiliary polynomial natin may iba yung itsura. I want to capitalize with theorem with the remark and theorem 3.4.3 para ma-solve itong GLDE na ito. Alright? So ang gagawin ko, gagamit ako ng exponential shift. Gagamitin ko yung theorem 5 pero sort of backwards or medyo I'll play around how to use theorem 5. So kapag ganito yung itsura ng differential equation na given sa atin, what I can do is to multiply both sides by e to the mx. Right? So i-multiply ko to ng e to the mx, f of d minus m, applied to y equals 0. And that is fine because e to the mx will never be equal to 0. So we are not reducing the equation to a trivial one. So ang ginawa ko lang, nag-multiply ako ng non-zero number, which is valid, right? Multiplication property of equality. But why did I specifically choose e to the mx? I chose it so that the exponent has coefficient m, which is the same as the subtrahend. At bakit ko siya pinili? Kasi i-apply ko yung exponential shift theorem backwards. Dito ka magsisimula, kukunin ko yung kabila. Right? Paano yung nangyari? Meron kang e to the mx. Gusto ko siyang ipasok dun sa loob. Pero pag pinasok ko siya sa loob, ang epekto ay nagkakaroon ako ng minus m. So, ibig sabihin pala, dapat ang minultiply ko both sides ay e to the minus mx. Alright? Kasi nangyayari pala pag ito naman, gusto kong ipasok dun sa loob, ang mangyayari ay magkakaroon ako ng f of d minus m. So, ibig sabihin, ma-minusan ko yung nasa loob ng auxiliary polynomial by m. So, naging d minus m siya dun sa loob. Right? So, that's why here, I want to multiply pala both sides by e to the negative mx. Para pag ginamit ko yung exponential shift theorem backwards, so ipapasok ko ngayon, magkakaroon ako ng f of something, papasok yung e to the negative mx dun sa loob, times y, equal kay 0 pa rin yan, okay? Tapos yung argument nung auxiliary polynomial f ay magiging d minus m, pero ang sabi ng exponential shift theorem, pag nagpasok ka ng e to the mx dun sa loob, ma-minusan mo yung original indeterminate kay little f by m. So whatever is originally inside little f, ma-minusan mo siya kung ano yung exponent nung exponential function na nandun sa unahan niya. So nasa unahan ni f of d minus m, or ang original ay d minus m, so you copy that over. Ima-minus ko sa kanya kung ano man yung coefficient ng exponent ni e. Ang coefficient ng exponent ni e ay negative m, so mama-minusan to ng negative m. And then if I simplify the argument of little f, we will get f of d e to the negative mx times y equal to 0. Okay? And then I can show you later how to solve this particular form. Okay, is that good? All right, I hope it is. So yun yung magiging ano natin. Yun yung magiging approach natin sa mga susunod na problems whenever we needed to apply exponential shift. So, particular example. Use the exponential shift to find the general solution to d plus 1 squared times y equals 0. Of course, I think this can be solved easily using Theorem 4, pero gamitin ko na yung exponential shift para masanay tayo para dun sa generic case. Ano? So what I'll do is to multiply both sides by e to the... Ano yung multiply ko? Kailangan ko siyang nalito ako bigla. I-multiply ko siya ng e to the x. Tama ba? Papayin ko nga yung papayin ko yung exponential shift theorem. Para may guide tayo, no? Oops. So ito yung exponential shift theorem. So what I'll do is I'll multiply both sides by, so kasi nama-minusan to by m, ito ay d plus 1. Gusto ko magkaroon siya ng minus 1. Alright? Para maging d plus 1 minus 1, magiging d squared na lang siya. So sinishift ko siya some units para mawala yung constant addend. Alright? So that means I need to have a d plus 1 minus 1 in the end. So kailangan meron akong e to the 1x, right? So I'll multiply both sides by e to the x. E to the x times d plus 1 squared y equals 0 pa rin yung right-hand side. Essentially, nag-multiply lang ako ng exponential function to both sides. Well, exponential shift theorem means if I want to put e to the x inside of my operator, right? So meron pa rin yung squared. Magkakaroon ako ng d plus 1, the original operator, pero minus whatever the coefficient to the exponent of e. Ang exponent niya ay x, ang coefficient ay 1, so magkakaroon ka ng minus 1 dun sa loob ng operator. Okay? And that will make everything simpler because the operator now will be reduced to the second derivative operator applied to ex, y equal to 0. Okay? Nawala na yung shift na plus 1 kasi in-offset ko na siya by multiplication by e to the mx. Okay? Tapos solve ko na. Second derivative na lang ito, ano? So basically here you're asking, kailan ang second derivative ay nagiging equal kay 0? Well, you can do it step by step, ano? Paano yung step by step? Well, this is derivative. The second derivative is just the derivative of the first derivative, right? E to the xy equal kay 0. So, ibig sabihin, naghahanap tayo ano yung mga functions na pag kinuha natin yung first derivative, nagiging equal kay 0. Right? Nagiging 0 lamang ang derivative kapag ka constant yung dinifferentiate mo. Right? So that means whatever we differentiated here must be equal to a constant. So that means d dx of e to the xy is a constant. Right? Kasi dito, dinifferentiate natin yung derivative ni e to the xy, ang sagot daw ay 0, so that means yung dinifferentiate natin, which is the derivative of e to the xy, must be equal to a constant. Right? Tapos ngayon, separable itong differential equation na to. So pwede akong actually hindi pala separable, pero I can play with the differentials. I can write it as d of e to the xy, or the differential of e to the x times y equals c dx. And then I integrate both sides. So here I'll get e to the x times y equals cx plus an arbitrary constant d. And then to find the explicit solution, I will multiply both sides by e to the negative x. So I'll have y equals cx plus d times e to the negative x, and that's our general solution. All right. Now, there's a shortcut here. You can say, at this point, second derivative daw ng e to the xy ay equal kay 0. Kailan ba ang second derivative nagiging equal kay 0? Nagiging 0 lamang ang second derivative kapag ka meron kang linear polynomial, right? So that's why si e to the xy dapat siya ay linear polynomial. Kasi nga, ang second derivative niya ay laging equal kay 0. Mga linear polynomials lamang ang may property na laging 0 yung kanyang second derivative. Alright? So kaya mula rito, pwede kayong dumiretso na rito because that step is obvious. Alright? The second derivative of this mystery function is 0. That means the mystery function is a linear function. So pwedeng isulat nyo na kagad, cx plus d yan. And then you multiply both sides by e to the negative x just to isolate y on the left side. So you will get the general solution. Okay? I hope that's clear. Sige, isa pang example. D plus 3 to the fourth applied to y ay equal kay 0. Again, I will apply exponential shift. What I'll do is to multiply both sides by what? E to the what dapat yung multiplier kasi nga. So, magkakaroon ako ng d plus 3 to the fourth applied to y ay equal kay 0. Kiefer says 3 to the x, and I think he's right. So e to the 3x yung i-multiply ko to both sides of our differential equation. Because exponential shift theorem tells us na papasok yung e to the 3x sa loob ng operator, but at the cost of shifting the indeterminate in our auxiliary polynomial by m units to the left. So ibig sabihin, ito ay magiging d plus 3 minus whatever the coefficient to the multiplier was. Ang coefficient sa exponent ng multiplier ay 3. So magkakaroon tayo ng minus 3 to the fourth applied to applied to e to the 3xy ay equal kay 0. So we'll be left with the fourth derivative of e to the 3xy ay equal kay 0. So how do you interpret this equation right now? Sabi natin, ang fourth derivative nung mystery function natin ay equal kay 0. So kailan ba laging 0 yung fourth derivative? Ano dapat yung forma ng ating mystery function? In that particular case, nagiging 0 lamang palagi ang fourth derivative kapag ka meron kang cubic function. Thank you, Billy James. That's correct, if you have a cubic function. So our mystery function, namely e to the 3xy, must be a cubic function. So you can write it as c1 x cubed plus c2 x squared plus c1x plus, but c1 na naman, c3 plus c4, dapat cubic function siya. And finally, to get an explicit solution, we just multiply both sides by e to the negative 3x. So we'll have y equals c1x cubed plus c2x squared plus c3x plus c4 times e to the negative 3x. And that is our general solution. That means lahat ng solution, ganito dapat yung itsura. There are no other solutions other than those can be written as a cubic function times e to the negative 3x, where c1, c2, c3, and c4 are arbitrary constants. So kahit anong function na ganito yung itsura, cubic times e to the negative 3x, will be a solution to this GLDE. Okay? Yan, 5 slides na lang. Tapos na tayo sa section 3.4. I hope I'm not going too fast. If I am, please tell me. Kasi nga, ang dami nating target today. Okay? Now, sige nga, quickly, what do you think is the solution here? Y equals what? Sige, mabilisan, 30 seconds. So, pang ano to? Pang math match, pang math wizard, pang mathlete. Ano yung solution sa ODE na to? So the solution is a quintic polynomial, right? So it's a c1 x to the fifth plus c2 x to the fourth plus c3 x cubed plus c4 x to the what? X squared plus c5 x plus c6 times what? E to the negative 7x, right? Kasi kailangan i-multiply ko both sides by e to the negative 7x. So this should be positive pala. Tama ba? Nalilito talaga ako dun sa sign na kailangan ko i-multiply. Kailangan ko itong i-multiply ng e to the negative 7x. Tama? Both sides. Para ito ay maging d minus 7 minus negative 7. So para siya ay mag-0. So magkakaroon ako ng e to the negative 7x sa left. Tapos mamaya i-multiply ko ng e to the 7x para mawala, para maging y lang yun nandun sa right-hand side. Sa left-hand side. So we have this solution. Okay? Pero of course, sa midterm exam, dahil hindi siya face-to-face, kailangan makita ko lahat ng solution. Alright? Kailangan nyo ipakita yung step-by-step solution dito. So basically, kailangan nyo ipakita kung ano yung minultiply nyo both sides, yung pagkaka-apply ng exponential shift. Tapos pag naroon doon na kayo sa d to the 6, e to the negative 7x times y equal kay 0, pwedeng after nito, ito na kagad yung kasunod. That's fine with me, right? Kasi alam nyo na talaga na yung mystery function dito dapat ay quintic polynomial. Alright? Or degree 5 polynomial. Tapos multiply nyo lang ng e to the 7x both sides, you will get this solution. Okay? And I think that ends this section. Right? Any questions? Nahapo ako doon. Parang super bilis ng pagkaka-discuss. But I hope that's fine with you. Now, in this practice exercises, problem number 1 is quite straightforward. Katulad lang siya ng ginawa natin kanina. Pero exercise number 2 will require a little bit of work. All right? Kasi nag-work lang yung ating function o yung ating method kapag 1 yung coefficient ni D. So rito kailangan kayo mag-factor out muna ng 3. So kailangan itong isulat muna as 3 times, 3 times D plus 2/3 raised to the 4th power. Alright? Tapos sila gagawin yung 3 times 3 raised to the 4th times D plus 2/3 to the 4th applied to Y equal kay 0. Okay? And then para mas madali, para hindi na kayo mag-worry about the powers of 3 na 3 to the 4th, though madali pa siyang computein, ano? But if you don't want to work with 3 to the 4th, you can divide muna both sides by 3 to the 4th para maging D plus 2/3 to the 4th muna siya Y equal kay 0. Okay? And that's perfectly fine. Then you apply exponential shift to this guy to get the solution. But of course, you can keep 3 to the 4th, but who wants to work with large numbers? Ano? When you can divide both sides by 3 to the 4th, the right-hand side remains 0 anyway, so this should be fine. Saka later naman, yung 3 to the 4th, i-absorb lang siya ng arbitrary constant C1 hanggang C5. So wala kayong magiging problema doon. Okay? Oh, I think this is a record for me. Natapos natin yung natitirang yung ilang slides in just 12 minutes. Any questions, guys? I hope this is good. So, punta na tayo dun sa last set of slides for the midterm exam. This is section 3.5. Titingnan naman natin yung generic ng way ng pagko-compute ng solutions sa GLDE when you have an auxiliary polynomial with constant coefficients. Kasi ang limitation ng method natin kanina ay actually at least before before theorem 3.4, ang limitation niya ay pag nakuha natin yung roots ng auxiliary polynomial, nakakuha tayo ng mga solutions. Tapos pwede natin kunin yung linear combinations ng mga solutions, we get another solution. But again, there's a lingering question there. Are those the only solutions, or is the linear combination of the solutions that we got the only solutions to the GLDE? Well, you can verify it again by checking linear independence. That will entail you using the Wronskian para makita kung linearly independent sila para makonclude na sila lamang yung solution doon sa ating GLDE. Ibig sabihin, the linear combination of the solutions we found by finding the roots of the auxiliary polynomial is the general solution. Pero dahil ayaw nating dumaan sa Wronskian, titingnan natin itong susunod ng mga concepts na ibabato ko sa inyo para mahanap talaga yung general solution without looking for the Wronskian, right? Now, we go back. So, ang requirement dito dapat yung ating GLDE, alright, ay merong auxiliary polynomial na constants lamang yung coefficient. Alright? So that means wala dapat variable na coefficient yung ating mga derivative operators. So meaning f of d should have constant coefficients lamang. Kapag hindi na constant, pag hindi constant yung kahit isa sa mga a sabays, then this method will not apply. Alright? So limited muna tayo sa constant yung coefficients ng auxiliary polynomial. Alright. Now, this is what we noted earlier. Kapag yung roots ng auxiliary polynomial ay magbibigay sa atin ng mga solutions kay f of d applied to e to the mx equals y. And actually, more than that, theorem 3.4 and 3.5 gave us ways on how to compute the roots or to compute the solutions to fd applied to y equal to 0 via the exponential shift. Pero balikan natin yung limitation before theorem 3.4. Paano mahanap yung general solution kapag nakakuha tayo ng roots ng auxiliary polynomial? Okay? Now, may tatlong cases. Una, kapag ka distinct yung mga roots ng auxiliary polynomial. Kapag ka distinct yung roots ng auxiliary polynomial, then of course makakakuha ka ng m1 hanggang mn. So halimbawa si f ay degree n. So sabi ng fundamental theorem of algebra, kapag ka meron kang polynomial of degree n, there would be at most n complex roots up to multiplicity. All right? So degree n si auxiliary polynomial, so meron tayong n complex roots up to multiplicity. So may tatlong cases. Una, iba-iba yung mga roots at lahat sila ay mga real numbers. And that is what is addressed by case number 1. Case number 2, may mga naulit na real roots. And in case number 3, may mga complex roots. So sa bawat isang cases na yon, makikita natin ano yung itsura ng general solution dun sa GLDE na f of d applied to y. Well, unang case, kapag ka distinct, iba-iba yung mga roots m1 until mn. Degree n si f, nakakuha tayo ng n na iba-ibang real roots, emphasis on the real roots. Then, sabi nung remark natin nung last meeting, alam nating solution si e to the m1x, solution si e to the m2x, solution si e to the mnx. So exponential raised to a root of the auxiliary polynomial times x, lahat sila ay mga solutions. Kung walang nauulit na m sabays, lahat ng mga solutions na yon ay linearly independent. That's what case number 1 is telling us. So no need to check the Wronskian. If you find the roots, or if you found the roots of f, and you notice na, oops, sila ay iba-ibang mga real numbers, then the solutions e to the root times x, lahat sila ay linearly independent. At dahil linearly independent sila, ang general solution ay yung linear combination nilang lahat. At sure na tayo ngayon na wala ng ibang solutions kundi yung mga nasusulat in the form of a linear combination of these exponentials. So yun yung conclusion na natin pwedeng masabi ngayon. Pag sinolve mo yung roots ng auxiliary polynomial, lahat sila ay iba-ibang mga real numbers, then linear combination lamang ng e to the root times x yung ating general solution. All right? Illustrations. So first, let's find the solutions to d squared plus 2d minus 3 applied to y is equal to 0. Well, the auxiliary polynomial is f of m equals m squared plus 2m minus 3. Lahat ng operator d ay pinalitan ko lamang ng variable little m para sabihin siya ay nag-stand siya for a number. All right? And then I can factor this as m what? M plus 3, m minus 1. All right? Pag inequate ko to kay 0, makukuha ko yung mga roots na to. Whose roots are m equals -3 and +1. And now we got two roots as expected kasi degree 2 yung polynomial. Fundamental theorem of algebra tells us there would be at most 2 roots up to multiplicity. Dalawa lang yung posibleng roots. Nakakita na tayo ng dalawang magkaibang roots. Magkaiba sila. Parehas silang real numbers, -3 and 1. Then, case number 1 tells us that the general solution to the GLDE, tawagin natin itong double star, is the linear combination nung e to the power root times x. So ito ay c times e to the -3x plus d e to the x. Yan na yung general solution. Okay? At alam ko, wala nang ibang solution kasi sabi ng case 1, linearly independent yung e to the -3x at e to the x. So wala nang ibang solution kundi yung mga ganito yung itsura. So I can say that this is the general solution to double star. Dali lang, no? Kapag ka distinct yung mga roots ng auxiliary polynomial. Okay? So in the interest of time, the next few examples, medyo hindi ko na isusulat yung mga buong sentences. I'll just mention them. Tapos makikita nyo na lang ay itong mga itong mga computations. Ano? Pero if you write your own solution, dahil wala naman ako sa harap nyo nung sinusulat nyo yung solution, kailangan yung isulat yung mga parts ng sentences. Ano? Pero dahil nandito naman ako, binabanggit ko yung parts ng solution, so isusulat ko na lamang yung mga hindi natin kayang i-mental. Just for the interest of time. And anyway, a complete solution to all of these examples are already in the handouts provided in the module for this week. Right? Okay lang ba yan? Kasi 10:51 na, ilang pang slides to? 44 slides pa yung kailangan kong i-cover. So hopefully we can do this. Okay. Okay, another example. So here our auxiliary polynomial is f of m equals m squared plus 2m. We factor this. This is m times m plus 2. And then i-equate ko siya kay 0 para makuha yung roots. So that means m is 0 or m is -2. This is the auxiliary polynomial is quadratic. Fundamental theorem of algebra tells us there are at most two complex roots. Tapos nakita na natin dalawang magkaibang real roots. So case 1 ito kasi wala nang ibang roots. So therefore, the solution to the ODE is a linear combination of e to the 0x plus n e to the -2x. So ang itsura niya ay C1 e to the 0x plus C2 e to the -2x. But e to the 0x is just 1, right? So this means this is C1 plus e to the -2x. End of solution. Sorry, nawala yung constant C2. Okay? Now, this one, cubic naman yung ating equation. Yeah, okay. Ito yung medyo mahaba yung solution. Madali lamang kapag quadratic kasi kaya nyo, madaling isolve yung roots ng auxiliary polynomial kasi pwede kayo mag-factoring or you can do quadratic formula. Paano kapag cubic na yung auxiliary equation? Yung auxiliary polynomial. For instance, number 3, we have y triple prime plus 2y prime minus 19y prime minus 20y. Pwede mo itong isulat as d cubed plus 2d squared minus 19d minus 20 applied to y equal kay 0. Right? Kasi yung derivative, siya lamang yung powers ni d. Third derivative, so meron kang third power ni d. Second derivative, meron kang second power ni d. First derivative, meron kang d, and so on. So here we have a cubic auxiliary polynomial. So in other words, our auxiliary polynomial is the one given in equation number 1, which is cubic. So kung laking quiz contest kayo, marunong kayo mag-cubic formula. Alright? Pero kung hindi, babalikan nyo yung rational root theorem. Anong sabi ng rational root theorem? Kung may rational na root yung equation number 1, those rational roots will be a ratio of the divisors of the constant term and the leading coefficient. Right? So, ang mga candidates para sa mga rational roots, kung meron mang rational roots, ay kukunin mo yung divisors nito divided by the divisors of the leading coefficient. This will work for any polynomial of any degree. Kaya ito yung una nating hinahanap. Pero ang drawback doon, hindi tayo sure kung merong rational root yung ating polynomial. Pero kung meron, sure tayo na siya ay ratio lamang ng divisors nito over divisors netong leading coefficient. Okay? So in particular, kunin mo yung divisors ni 20. So you'll have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Tapos ang coefficients ang divisors ng coefficient ni m, luckily for us, 1 lang yung coefficient niya. So ang kanyang divisors lamang ay plus or minus 1. Ang laking problema kapag ka ang divisor, kapag ka ang coefficient nito ay maraming divisors. Halimbawa, halimbawa ito ay 40. So, ang daming divisors ni 40. So, ang dami ng possible Qs. Tapos, kukunin nyo lahat ng posibleng P over Q. At doon kayo titingin sino sa kanila yung mga rational roots. Kasi sila yung mga kandidato para maging rational roots ni equation 1. But again, they are only candidates. We don't know if there are rational roots at all. Pero if there is a rational root, sure tayo na isa siya sa mga P over Q where P and Q have these possible values. So meron tayong ilan? 1, 2, 3, 4, 5, 6. Meron tayong 12 candidates para maging rational roots. 20 over 1, negative 20 over 1, 10 over 1, negative 10 over 1, and so on. So yun yung mga candidates. Well, paano natin ma-check kung yung mga candidates na yun ay mga roots? Well, you can plug in those numbers here and see if you'll get a 0. Okay, pero mahirap yung gawin. Usually, ang ginagawa natin ay synthetic division. Na-discuss ba sa inyo nung high school yung synthetic division? I hope na-discuss nyo siya. Kasi halimbawa, ang una kong kuning candidate ay halimbawa si 2. So, kung si m ay equal kay 2, kasi gagawin ko to sa lahat ng mga to, sa 12 na to. Pero you do it one at a time, ano? So, tingnan mo, si m equals to by root. So, dapat pag nag-synthetic division ka, dapat ang remainder ay 0. If you can't remember synthetic division, kindly look for resources, review synthetic division, but you'll get a table like this if you perform the synthetic division, okay? Pag nag-synthetic division ako by 2, ang makukuha kong remainder ay negative 42. That means m equals 2 is not a root of our cubic auxiliary polynomial. So pupunta ka na dun sa iba pang candidates. So 11 down. Alright? So pili pa tayo ng isa. Halimbawa si m ay equal kay 4. Synthetic division ka. M equals 4. Uy, remainder ay equal kay 0. So ibig sabihin, we're good. Nakakuha na tayo ng isang root. And remember, we have a cubic polynomial, so dapat bababa na ng isang degree. Kasi remember, by the factor theorem, kapag ka si m is a root of polynomial p sub n of x, where p sub n has degree n, ibig sabihin si p sub n ay pwede mong isulat as x minus m times a polynomial of degree n minus 1. Kasi kapag ka si m ay root ng isang polynomial, ibig sabihin si x minus m ay factor ng polynomial. Yun yung sinasabi ng factor theorem. So pwede nating i-factor out yung x minus m, matitira ka with a polynomial of 1 degree less. At ganun yung mangyayari dito. So ibig sabihin yung ating auxiliary polynomial kanina na cubic ay pwede kong isulat, actually siya pala ay si f of m, ano? Pwede ko siyang isulat as m minus 4. I'm sure of that because 4 is a root of our auxiliary polynomial. So ibig sabihin factor siya ng auxiliary polynomial. Tapos times whatever is left in the synthetic division. So this guy is the coefficient to m squared. This is the coefficient to m. This is our constant, right? So ibig sabihin yung natitirang factor ng auxiliary polynomial ay si m squared plus 6m plus 5. And lucky for us, m squared plus 6m plus 5 is quadratic, so we can easily factor it or apply the quadratic formula. So now we get f of m equals m minus 4 times m plus 5 times m plus 1. So what do we see here? Meron tayong tatlong roots at lahat sila ay distinct at real, right? At wala nang ibang roots kasi cubic yung ating auxiliary polynomial. Again, fundamental theorem of algebra tells us tatlo lamang yung maximum roots. Nakita na tayo ng tatlo, so sure tayo, ang mga roots lang natin ay si 4, si negative 5, at saka si negative 1. So therefore, the general solution to our GLDE is C1 e to the 4x plus C2 e to the negative 5x plus C3 e to the negative x. Right? Kasi ang mga roots natin ay 4, negative 5, at negative 1. So linear combinations ng mga e to the power root times x yung ating general solution. So yan yung ating general solution. So medyo matrabaho yung paghahanap ng roots ng auxiliary polynomial, especially if ang laki ng degree ng auxiliary polynomial. Pero kung quadratic lang naman yan, madali lang. Pwede kayong mag-quadratic formula or factoring kung pwede. Okay? So, yun yung isa yung kailangan paghandaan, pag-aralan, paano nga ba kumuha ng roots ng polynomial uli. At dahil hindi face-to-face yung exam, at para malaman ko na hindi kayo nag-online solver, kasi ang tinetest namin sa 151 ay kung kaya nyo mag-solve by hand. So, kailangan nyo ipakita yung paghahanap ng roots ng auxiliary polynomial. Okay, so I hope you take note of that. Hindi pwedeng gumamit ng online solver sa pagko-compute ng roots ng auxiliary polynomial. Kailangan ipakita nyo yung solution. All right? Okay, so yeah, we saved some slides there. Next case na tayo. So, kanina na-address na natin paano kapag distinct lahat ng roots at real silang lahat. What if may mga naulit? Okay? Kapag merong repeated roots, halimbawa si m ay root ng auxiliary polynomial of multiplicity k. Ibig sabihin, pag finactor mo yung auxiliary polynomial, meron kang x minus m to the k. Right? So, ibig sabihin, k times siyang naging root or siya ay isang root of multiplicity k. Ang sinasabi ng ating case number 2 ay ganito lamang. Ang mga linearly independent solutions ng iyong GLDE ay e to the mx. So si m yung root natin, So meron kang e to the mx, tapos x times e to the mx, x squared e to the mx, hanggang makapunta ka kay x to the power k minus 1 e to the mx. So ito ay kapag meron kang nauulit na roots. All right? Now, you can simplify this and you can say na, okay, pag kinuha ko yung linear combination nilang lahat, so magkakaroon ako ng C1 times e to the mx. Sige, expand ko nga to para mas makita nyo yung nangyayari. So, ito ay C1 e to the mx plus C2 times Y2. So, copying ko si C2, tapos si Y2 daw ay equal dito. So, I'll have x e to the mx plus C3 x squared e to the mx until makarating ako kay ck x to the k minus 1 times mx. Alright? So siya yung expansion ng sinasabi sa atin ng theorem ng case number 2. Well, lahat sila ay may e to the mx. Sorry, nawala yung e to the mx doon. Lahat sila ay may e to the mx. So pwede mong i-factor out si e to the mx times a polynomial, c1 plus c2x plus c3x squared until c to the k, c sub k x to the k minus 1. So magkakaroon ka lamang ng e to the mx times a polynomial of 1 degree less than the multiplicity of the solution. So kung multiplicity k yung ating solution, k times na naulit si m, then ang general solution ay e to the mx times a polynomial of degree k minus 1. Pero nakita na natin to kanina, di ba? Nakita na natin to dun sa solutions natin sa d minus m raised to the n applied to y equal kay 0. Nakita natin exponential lang to times a polynomial of degree n minus 1. So yun lamang yung sinasabi ng case number 2, which is a duplication of a result that we have observed earlier when you use the exponential shift. Okay? So ito yung gagawin kapag ka may nauulit na roots. So siguro it would be more concrete if we look at a specific example. So this case, let's solve the differential equation d squared plus 6d plus 9 applied to y equal kay 0. Our auxiliary polynomial is a quadratic one, and it is m squared plus 6m plus 9. But this is a perfect square trinomial because you can write this as m plus 3 quantity squared. So this means that negative 3 is a root of multiplicity 3. Okay? Sorry, multiplicity 2. Kasi twice siyang naulit as a root. Kasi yung x minus 3 or yung m minus 3 ay twice nag-appear as, yung m plus 3 ay twice na nag-appear as a factor of the auxiliary polynomial. So naulit si negative 3 as a root 2 times. Kasi meron kang factor na m plus 3 na 2 beses. So si negative 3, 2 beses din na naging root ng auxiliary polynomial. Sabi ng case number 2, kapag ka meron kang nauulit na root, ang general solution ay ganito yung itsura. E to the mx, so e to the negative 3x times a polynomial of degree 1 less than the multiplicity of the root. Meron tayong root of multiplicity 2. So ibig sabihin magkakaroon to ng linear polynomial na multiplier. So that's the general solution. Okay? Or you could have solved this using exponential shift. Parehas lang yung makukuha yung solution because if you apply exponential shift, you can write the operator as d plus 3 squared applied to y equal kay 0. Natutunan natin sa exponential shift, kailangan nating mag-multiply ng e to the 3x to both sides, right? Para ma-shift yung differential operator. Para ito, papasok si e to the 3x sa loob ng operator. Yung operator magiging d plus 3 minus 3 squared e to the 3x y equal kay 0. So this would be the second derivative of e to the 3x y ay equal kay 0. Pero kailan nagzi-zero ang derivative, ang second derivative? Nagzi-zero ang second derivative palagi if and only if the mystery function is a linear function. Okay? And then you multiply both sides by e to the negative 3x to find the explicit form for y, and voila, you get the same answer. Okay? So it doesn't matter which one you use, which method, you come up with the same general solution. Okay? So ganun yung trick kapag ka meron kang repeated root. E to the root times x times a polynomial of 1 degree less than the multiplicity of the root. Okay? Oops. So mabilisan. D minus 2 cubed y. So we know that m equals 2 is a root of multiplicity 3. Kasi thrice siyang mag-appear as a root. Si m equals 2, right? Kasi si x minus 2 ay 3 beses na factor ng ating auxiliary polynomial na m minus 2 quantity cubed. So that means by case number 2, ang general solution natin dito ay e to the mx times a polynomial of degree 1 less than the multiplicity. Multiplicity 3 tayo. So yung polynomial multiplier natin ay quadratic. So we get c1 plus c2x plus c3x squared. There we go. That's our general solution. Parang ang bilis, no? Ang bilis lang pala mag-solve ng differential equations kapag ka madaling i-factor yung auxiliary polynomial. And the only requirement here is that the auxiliary polynomial has constant coefficients. Dapat, dapat constant lahat ng multipliers dun sa mga derivative operators. The fun thing about these cases ay pwede silang mag-occur side by side with each other. Okay? Halimbawa, sa example number 3, ito na. D squared minus 1 at saka D minus 2 quantity cube. So ang auxiliary polynomial natin dito, which luckily is in factored form na kagad, ay m squared minus 1 times m minus 2 cubed. So ito ay what? This is quintic. So degree 5 to. So meron tayong at most 5 complex roots or exactly 5 complex roots up to multiplicity. Pag in-equate mo to kay 0, makukuha mo yung roots. Ano yung mga roots ni f? Ang mga roots ni f ay plus or minus 1. Then ang galing dito, oy, distinct yung mga roots, so that's good. Pero dito, mayroong mga naulit. Actually here, we see that 2 is a root of multiplicity 3. Kailangan lang natin gawin, kunin yung sum ng mga general solutions para dito at general solutions para rito. Okay? So separate nating i-process yung mga roots ng auxiliary polynomial depending on what case they fall under. Tapos isasum lang natin yung dalawang general solutions. So in particular, so ano yung general solution natin dito? The first, we have 2 simple roots. Ibig sabihin, dalawang real roots na distinct, na hindi na ulit. So ibig sabihin, meron tayong linear combination na manggagaling dun sa dalawang distinct roots by case number 1. So we will have C1 e to the x plus C2 e to the minus x. So ito yung solution na nanggaling dun sa dalawang distinct real roots. Now, we need to take care of yung natitirang mga roots. Si 2 yung natitirang root pero ang multiplicity niya ay 3. So mag-a-apply para sa kanya yung case number 2. Okay? Sa case number 2, ibig sabihin, sabi niya, magkakaroon tayo ng e to the root x, so e to the 2x, times a polynomial of degree 1 less than the multiplicity. Multiplicity 3 yung root natin, so dapat meron tayong quadratic polynomial. So I will have C3 plus C4x plus C5x squared there. And that's our general solution. Okay? Any questions? Questions? Everything's fine? Or masyado bang mabilis? Ako yung napagod, hindi ako sanay mag-discuss ng ganito kabilis. Pero I hope you can follow. Ano? Simple lang naman yung algorithm or simple lang naman yung process. Ano? You just need to remember the cases. Now, the most complicated is when you have complex roots. Okay? Kasi posible na complex number yung mga roots. Hindi na pwede yung ginagawa natin na kapag walang root, halimbawa si m squared plus 1, sasabihin natin na there exists no real roots. Totoo naman yon. Pero that will not prevent us from finding solutions to this general linear differential equation when there are complex roots in the auxiliary polynomial. But just a quick recap of, or a quick look at complex numbers. Hopefully you have encountered complex numbers before. Pero kung hindi, ang mga complex numbers, ang itsura niya ay a plus ib. Si a at saka b ay parehas real numbers. Pero si I, siya yung imaginary unit. Siya yung number na pag in-square natin ang sagot ay negative 1. A is called the real part of z. Tapos si b, siya yung tinatawag natin na imaginary part ni z. So may dalawang parts yung isang complex number. Meron siyang real part, siya yung walang multiplier na I. Yung imaginary part niya ay si b, yung multiplier ni I. And again, I is the imaginary unit with a unique property ng I squared ay equal kay negative 1. Okay? Now, ang solution kapag meron kang complex roots ay exponential pa rin. Pero nagiging complex exponential na siya. So it is important for us to learn how to compute e to the power z, where z is a complex number. Now, ito yung formula. So, kung gusto nating isulat si e to the z, where z is the complex number a plus ib, so itong z, lalagay ko lang siya dyan, nag-a-apply pa rin yung loss of exponents sa complex numbers. So, pwede ko itong ipaghiwalayan as e to the power a times e to the ib. Okay? Loss of exponents lang yung ginamit ko rito. Nag-a-apply pa rin siya sa complex numbers. Now, the peculiar thing is what happens to e to the ib. Kasi yung e to the a, okay lang yan. Kasi si a ay real number, e to the a is the usual e to the a. Pero ang crucial dito ay yung e to the ib. Yung e to the ib natin, ang itsura niya, merong formula sa complex arithmetic dito. Ang e to the ib ay cosine ng b plus I sine b. Ito yung trigonometric form ng complex number e to the ib. I will not go into the details why this happened. You have to wait until Math 165 for you to learn the motivation behind this definition. But if you have e to the ib, that is just cosine ng b plus I sine b. Okay? So ito yung trigonometric form ng complex number e to the ib. Okay? Now, ito yung sinabi ng slide. Okay? So, ito yung itsura. And then, titingnan natin ngayon, ano yung itsura ng solution kapag ka meron tayong complex roots. Pero before we go there, okay, or actually, pwede mo na ma-conclude na yung f of d applied to y ay equal kay 0. We'll have this general solution when the complex number z is a solution to the auxiliary, is a root to the auxiliary polynomial. So halimbawa, si f of z ay equal kay 0. So mag-apply yung remark natin sa section 3.4 na kapag ka nakakuha ka ng root ng auxiliary polynomial, yung e to the root ng auxiliary polynomial ay solution dun sa ating GLDE. Pero ang root natin dito ay complex. So siya ay a plus ib times x. So, ibig sabihin, ito lamang ay e to the ax times e to the ibx. Alright? So, pag in-apply niyo yung formula kanina sa pagko-convert ng complex exponential papunta sa trigonometric, so magkakaroon ka lang ng e to the ax, kokopyahin mo lang yan dito, kasi ito ay magiging cosine ng anuman yung multiplier kay I. Kaya nagkaroon ako dito ng cosine bx plus I sine ng bx. So this is one of the solutions of this GLDE. Pero again, we don't stop there. We want to find all the solutions. We want to find a formula for the general solution of the GLDE. Now, how do we find that? Well, we need this remark from complex numbers. Ang sinasabi lang ng remark na to, kapag ka si a plus ib ay solution, ay root ng isang polynomial, sabi ng isang theorem sa complex number, yung conjugate niya ay dapat solution din. Alright? So laging yung mga complex roots, they always come in pairs. Si z at saka yung conjugate niya ay parehas solutions. What do we mean by conjugate? Babaguhin mo lang yung sign ng imaginary part. So kung meron kang a plus ib, kung siya si z, ang conjugate ni z, denoted usually by z bar, ay equal kay a, papaltan mo lang yung middle sign, ib. So ninenegate mo lang yung imaginary part. Yun yung conjugate. And sabi ng theorem natin dito, o ng remark na to, kapag kasi z ay root ng iyong auxiliary polynomial, then yung conjugate niya ay root din ng auxiliary polynomial. Because again, complex numbers or complex roots always come in pairs. Okay? So pagka si a plus ib ay solution ng auxiliary equation, so si a minus ib ay solution din. Hindi siya magpapatalo. Alright? So ibig sabihin, pag nakahanap ka ng isang complex root, automatically dalawa yung nahahanap mo. yung si Z at saka yung complex conjugate niya. Which brings us to have two solutions. So aside from e to the ax cosine ng bx plus I sine bx, ito rin ay solution doon sa ating auxiliary equation. A solution din doon sa GLDE. Actually, nawala yung I dito. Double check ko nga. Yeah. Dito lang siya nawala. Dapat may I dito. Cosine bx minus I sine bx. So combo lagi yan. Dalawa yung nakukuha natin na solution right away. Alright? Hold on. Parang may kulang. Yeah, nawala yung mga I's. Bakit siya tinanggal nung slide? But anyway, let's just add them here. Dapat may I yan. Tapos ito ay may I. Okay. Now, you can trust me that the two solutions we got from the complex roots, namely e to the zx at saka e to the conjugate ni z times x, they are linearly independent. So that means the general solution, if you only have two complex roots, all right, the general solution will be a linear combination of e to the zx and e to the z conjugate x. So yun yung sinasabi ng slide na to. Actually, naging conservative siya. Sinabi niya lang is a solution. Okay? Now, paano natin siya i-manipulate? Well, kunin mo yung linear combination. Ito yung solution na nanggaling kay a plus ib in trigonometric form. Tapos ito yung solution na nanggaling kay a minus ib in trigonometric form again. And we get the linear combination of these two solutions. Tapos, kapag kinumbine natin yung like terms, alright? So I'll have, pagsasamahin ko yung may mga cosine bx. So I will have c1 e to the ax times cosine bx plus c2 e to the ax times cosine bx. So pwede kong i-factor out si cosine bx from that group, actually pati si e to the ax, so magkakaroon lang ako ng multiplier na c1 plus c2. So that's okay, right? Tapos ngayon, i-collect ko naman yung mga may sine bx. Well, I will have c1 e to the ax times I sine bx plus c2 ax times negative sine bx. So pag ginawa ko yon, meron akong common factor na dapat meron pa tong times I. So magkakaroon ako ng common factor na e to the ax sine bx times I times C1 minus C2. Alright? Pero yung C1 minus C2 ay constant. Si I ay constant din. Siya ay imaginary unit. Dahil constant din si I, pwede ko na lang siyang isama dun sa arbitrary constant C1 minus C2. So essentially, my D2 here ay actually C1 minus C2 times the imaginary constant I. Kaya dito sa final itsura ng ating general solution, nawala na yung complex unit I. Kasi yung complex unit I nakatago na kay D2. So if you want to keep your solution to be a to be in the realm of the real numbers, then eto na lang yung isulat natin. Alright? Para mawala na yung complex number na I. Okay? Now, I guess this is the farthest that I can go now. There are still 18 slides in here, but I guess that's fine. Siguro balikan na lang natin yung mga examples on Wednesday para lang for completion of the discussion. But I guess this is sufficient. Naabot naman natin yung kailangan niya para sa sa midterm exam. Which part, Victor? Yung pagsisimplify ba? Yes. Dun sa pagsisimplify, ang kailangan nyo lang gawin ay be patient with the expansion. So, meron ka nito, linear combination na yan, expand mo lang. So, kunin mo yung apat na terms. So, meron ka nito times this guy, tapos ito times that guy, alright? Plus this guy times that guy, plus this guy times this guy. Alright? So, magkakaroon ka ng apat na terms. Tapos, igrupo mo yung may mga cosine bx. Ay, may mga e to the ax cosine bx. Tapos, igrupo mo yung may mga e to the ax times sine bx. Okay? So, pag ginrupo mo na sila, okay, makukuha mo yung common factor nila. Ang common factor ay C1, i-factor out mo yung e to the ax cosine bx mula dun sa group na parehas may e to the ax cosine bx. So ito yung makukuha mo. Tapos dun sa pangalawang grupo na may sine bx, ito naman yung makukuha mo. Alright? Tapos ang gagawin mo ngayon ay palitan lamang itong C1 plus C2. Gawin mo lang siyang D1 kasi C1 plus C2 are just arbitrary constants. Rename it to D1. Tapos yung C1 minus C2 times I, rename it to another variable. Tawagin mo siyang D2. So ito yung itsura ng solution. And of course, case number 3 works in tandem with the previous cases. So pwedeng sama-sama yung tatlong cases sa isang problem. Pwede ka makakuha ng mga simple roots, tapos merong nauulit na roots, tapos merong complex roots. Alright? So, pero kukunin mo lang naman yung sum ng mga general solutions mula dun sa tatlong cases. So that is what the examples will tackle, but unfortunately we don't have time to go over them. So I'll start on this slide on Wednesday. But I guess you're in a good shape to do the midterm exam. Kung kukulangin man, you can do some reading, slides 22 onwards, nung section 3.5. Pero I guess sufficient na yung na-discuss natin para sa midterm exam. Speaking of, if you have classes, you can go and just watch the last few minutes of the recording. I'll just give some hints or some ideas about the problem set that will come live later in Canvas. 5 p.m. lalabas na yung problem set. Tapos ko na siyang isulat. May tatlong parts yung problem set. Yung midterm exam. Part number 1, you need to solve 4 differential equations. So sa part number 1, 1A, 1B, 1C, and 1D, meron akong 4 na differential equations. Okay? I-solve nyo siya any method that you want. Okay? Pero may twist. Ano yung twist? Tatlo sa kanila, kailangan yung i-PDF yung solution. Alright? So, na magkakahiwalay na PDF para hiwa-hiwalay nyo siyang i-upload. So, bawat isang problem, meron siyang sariling submission bin. So may problem 1 point, merong midterm 1 point, merong midterm 1.A, 1.B, 1.C, 1.D. Doon sa tatlo sa kanila, PDF yung isa-submit nyo. Pero pipili kayo ng isa sa kanila na magiging video problem nyo. Ano yung video problem? Pili kayo ng isa dun sa 4 kahit alin. Kailangan nyo lang mag-record na ine-explain nyo sa akin kung paano yung solution. Okay? So parang video recording na dinidiscuss nyo sa akin yung solution. You are free to choose which one of the 4 yung gagawan. Kaya medyo siguro you'll spend another extra 30 minutes or 1 hour to prepare the video. Huwag nyo na masyadong effortan yung video. So pwedeng magsulat lang kayo, screen share, and then voice it over. Or kung wala kayong pen, pwedeng picturean nyo lang yung step-by-step ng solution na sinulat nyo sa papel, tapos i-copy-paste nyo dun sa slide, lagyan nyo ng animation, i-record nyo using PowerPoint, then that's fine. Hindi to pagandahan ng video. Kailangan lang maintindihan ko, makita ko kung paano nyo i-explain yung solution dun sa 4 na problem. Okay? So each of those problems is worth 10 points. So part 1 will be 40 points in total. Tapos, part number 2 is a conceptual problem. So meron dun dalawang theoretical problems, ano? So it's either a proving problem or find a solution or find a formula, all right? Pero pipili lang kayo ng isa. Sa part 2, pipili lang kayo ng isa, yun yung sasagutan nyo, yun yung i-upload nyo as midterm 2. All right? Isa lang. And you get 10 points from that. You choose exactly one of the two problems. And then there's a third part, which is an application problem. Meron akong dalawang word problems. Pipili lang kayo ng isa kung alin yung sasagutan nyo, and that is worth 15 points. So bali, all in all, you'll get 65 points possible for the midterm exam. Okay? Pero don't worry, nandun naman sa questionnaire yung solutions. Gusto ko lang siyang banggitin so that you have an idea. And again, I won't accept any late submissions. The deadline is strictly 11:59 on Monday. So give yourselves ample time. In case of some contingencies or emergencies, kung mawawala ng internet, make sure all your works are submitted right before midnight. And just to be safe, pag natapos na kayo ng isang problem, upload nyo na kagad. Kasi hiwa-hiwalay naman yung gagawin kong submission bins. Okay? And that's it. I think that's all for now. Sorry kung medyo mabilis yung discussions para maabot ko tong slide na to. Pero I hope you got the gist of the topics. So good luck on the problem set, and let's see each other again on Wednesday. Bye, everyone.